and a very warm welcome to everyone. Greetings to all of you. Hope you guys are doing great. So today we're gonna be discussing some of the latest technologies that are in trend with the latest research which have been developed over the years in AI, and we're gonna talk about how it all comes together and functions just like it's functioning right there on the screen. So in front of us, what's currently working on the base model is computer vision, which helps us analyze images, videos, and can be this technology, which could be installed in robots, can help us enable walking robots. And if you can embed this technology into a car, which Elon Musk has developed, it would create a self-driving car which can navigate itself. So how do these technologies come, like how does this whole piece of art works together? We're gonna be discussing some of the things and how do they function. So let us begin. So this comes down to the task of being able to tag like tag a person, a car on the road, truck, traffic lights. So first of all, we need a computer to be able to understand, to differentiate between a person, a car, a truck, and all of this should happen in real time. And so this AI or algorithm must learn to understand of how is this functioning, or what is it, the thing that we have to classify. So another thing that has been trending, so let's discuss some other technologies as well that are trending right now. So you can talk to Alexa here. Okay, Alexa, how's the weather today? And Alexa can tell you the weather. So this kind of technology is called natural language processing, in which we are processing natural language or linguistics. Natural linguistics we are processing into a form of code that is being understood by the computer, and then computer begins to translate it into its own binary language, and then gives us the response of what should be the appropriate feedback in our language, which we do understand. So these technologies can also be used in many sectors depending upon the creativity. It can be used in a bank as well. Like, okay, there is some problem, there is a person who is undergoing some problem with the bank and he's not able to, say, withdraw money. So a robotic assistant could be placed there instead of a person who is working his 9 to 5 job, dedicating his whole life to the bank, and then there could be a robot that could be doing the same job. So like Alexa can just, Alexa can be trained to have queries about it has to be trained first on what all it can do and how it should happen. Correct? Yeah. So that is the way we can. So first we have to train the algorithm. So through this previous example of computer vision, where we trained images, so we are making a computer understand on what is happening. Correct? So here also we are trying to make the computer understand on what is happening, what are we trying to say. So there's another technology which I would like to discuss, that is Amazon Look. So this is a camera. This is a normal camera which has been programmed. It's collision between Internet of Things and AI. So these uses smart algorithms, to tell us an opinion about our outfit which we are wearing. It's like a personal style assistant, which we can say. So this tells us, gives us a second opinion about how good we are looking today, on what should match better with black trousers. Should a white will make good contrast, or gray, or whichever goes. What kind of shoes should I wear with say black tee or say white t-shirt? So then the question comes to mind, how are we able to do the task of making a computer learn? Or what is machine learning? So a computer that is set to learn from experience E with respect to some task, to say T, on some performance measure which is P. It is the performance on T as measured by P improves with experience E. Then congratulations, we can call it machine learning. That the machine has been successfully programmed to do the task that we wanted to do. So it's an application of artificial intelligence that is working here, that provides us the ability to automatically learn and improve from experience without being explicitly programmed. So it's like you have given a training to a new manager that has just joined the company. So first you have to train him on how he should work. Sometimes he might come to you asking for a suggestion about what should be done in such and such situation. But once he is learned, so without being explicitly programmed, he will do the task for you. It's like a training that you are training your new manager. It's like you're training a new algorithm. So machine learning focuses on development of computer programs that can access data and use it to learn for themselves. So it's not like machine says, okay, I don't want to come back to you every time, so I will try to make it happen by myself. I want to learn what is happening. How are you able to do the task that I'm not able to do? So the process of learning begins with observation or data, such as examples, direct experience, or instructions. So in order to look for patterns in the data, we must make better decisions and make better decisions in the future based on example that we provide. So the primary aim is to allow the computers to learn automatically without human intervention. It's like teaching a baby. It's like teaching an AI. AI doesn't know for himself or herself that what has to be done. It's like first time he or she has seen this problem. Now the question is, how is it gonna do that? So there are different methods for allowing her to do that, and there are different types of machine learning which can be used for different sort of problems that do occur. So the first one being supervised machine learning, my favorite one. So supervised machine learning, as the name suggests, supervised, that means it's under supervision. It's like supervised learning. You are learning, the child is learning under the supervision of a teacher or the parents or the guardian, whoever is teaching. So it's the learning of a task during our school days, we used to learn from our homework. We used to get some homework assigned, for say from math subject. So after solving the problem, there used to be the answers on the last page, just to be on the safer side and to check whether we have applied the right logic to be able to arrive at the right output. So there always used to be a page where you could verify whether you have followed the right logic or not. So same criteria, same molecular base is used in supervised machine learning. So it's the machine learning task of learning a function that maps an input to an output based on the example input-output pairs. So it infers a function from labeled training data that is consisting of a set of training examples. So say you want to train on how to differentiate between a cat and a dog. So you show how a cat looks and how a dog looks, and then you can ask, okay, now tell me. Now I have already shown you a picture of a cat and dog. Now you tell me how is this a cat or dog? So you have shown an output to him or her. So similarly, uh, say in each example there is a pair that is consisting of an input object that is typically a vector and a desired output value, that okay, this is a picture and this is the label that it is a cat, and there's another picture and there's another label, or that this is a dog. So a supervised machine learning algorithm analyzes the training data and produces an inferred function which can be used for mapping new examples, as we just discussed. Now again, like we were just discussing about the types of machine learning that are there, now let's discuss some subtypes of, or some types of problems that can be solved using, that can be used in supervised machine learning. One is classification and another one is regression. So in classification problem, there's a, so what do we do in when we have to classify? Like we have to classify say a group of cats or a group of dogs together. We will classify them together. So same here, we can so supposedly you're analyzing some MRI, that is magnetic resonance images, using computer vision. So you have to label, you will get your data labeled like disease, is there brain tumor in this image, or there is no tumor in this image. So you will get a labeled output, that is classification. So it will be classified disease or no disease, like tumor or no tumor, you know, like pass or failed. Yeah, did you pass the exam, did you fail the exam? So it would be a label. So these are the classification problems where you have to differentiate, like classify whether it's a cat or a dog. So when these kind of problems occur, it's usually a classification problem. So here you are looking to classify things. So when you're looking for predicting dollars, like tomorrow's stock market price, or say some height with respect to weight, or some house value, whether the house value of 3 BHK is that is located in the center of the city is greater than 3 BHK that is in the rural areas. So supervised machine learning algorithms can help us solve classification problems, regression problems, and include some recommendation, time series prediction, like we were just discussing, predicting stock market prices for tomorrow, for day after tomorrow. So these are some examples of linear regression. Some popular examples of algorithms which are used, so like linear regression is used for regression problems. Then there is a random forest, which is an hybrid algorithm which can be used for classification as well as regression problems. Then we come to support vector machine. These are exclusively designed for classification problems. And decision trees. So decision trees is a subset of the greater random forest algorithm. So these two have the same functioning base. The mathematical science behind decision trees and random forest work in similar fashion. Decision tree can be used for smaller problems, while When it's a big forest full of data, random forest is the solution. So these are some keys which are really helpful, which will be really helpful for you in the future when you come across different sort of problems, so you know which puzzle, which part to fit in which puzzle. So then we come to another sector of machine learning algorithm, which is unsupervised. So unsupervised algorithms, so these are good for data that is not known to us. So data which is known to us, which is labeled, we can form some supervised learning on that kind of data, which we'll be doing in the coming tutorials. So, but when there is no label provided, that there is no output variable, whether this is a cat or this is a dog, so then the AI is left for herself to do the prediction. So then we come to another form of learning of algorithm, which is unsupervised machine learning. So here you only have an input data and there is no corresponding output variable. So the goal of unsupervised learning is to model the underlying structure or distribution in the data in order to learn more about the data. So you're creating structures within the data that will help you learn more about the data. So these are called unsupervised learning, because unlike supervised learning above, there is no correct answer, there is no teacher. AI is left for herself to be the teacher. She has to be her own teacher here. So to discover and present interesting structures in the data. So this was a brief on supervised and unsupervised machine learning algorithms. So in the coming lectures we'll be discussing some other areas of machine learning, and we'll also be covering some depths of neural networks, which are the building blocks for doing deep learning, that is after machine learning. So lots of interesting lectures coming up. I hope you guys stay tuned and see you guys in the next lecture. Have a good day and happy learning.